Okay, so happy snow day. We're just going to finish a few of the examples that we had from yesterday's class. So if we take out your notes from yesterday, we can look at this particular example. Now this is not this figure doesn't have a triangle in it yet, but what we can do is we can draw the opposite side of the rectangle. We can call this x. So now this value is 10. If that length is, or if this whole length is 10 and this length is 6, then what do you suppose that length is? This is 4. So we have a right angle here, and so if we have our legs, x squared plus 4 squared equals 12 squared. Now we have x squared plus 16 equals 144. Now when we subtract here, we're going to say, all right, this is 128. And the square root of 128, we can look at this, and we can say, okay, let's divide 128 by 4, and then we can get 32. But then 32, we can say 16 and 2. So this is really 64 times 2, so this is 8 root 2 would be the value of x. All right? And now for the next problem, solving for x. So this is a little different, and this involves some factoring. So if you try this, if you haven't tried it, try it now, and then come back to it. You can hit pause on the particular video. So we have our legs. Squared equals the hypotenuse squared. So remember, you have to expand and multiply and use the FOIL method here. So we'll have our first terms, outer terms, inner terms, last terms equal 100. So we have 2x squared plus 4x plus 4 equals 100. And now when we subtract 100, we're going to use the zero product property, something that we discussed last week. And we have 2x squared plus 4x minus 96 equals 0. Now everything here is divisible by 2. So if we divided everything by 2, that can simplify the problem for us. And so we can say x squared plus 2x minus 48 equals 0. Okay. And now we can say, all right, what are factors of 48 that add up to 2? So we have x plus 8, x minus 6 equals 0. And now we're using our zero product property to solve. So we reviewed this last week, and it's okay if this is still giving you some trouble. This is a bit of a challenge problem here. But notice how our x is a length. We can't have negative length. So you have to reject that answer. So x, we'll say, is 6. All right, so try that one again if you want to, but this is a bit of a challenge problem, an extension problem, and you may have had some on your homework like that. So for 7, we have there are 2 legs squared equals our hypotenuse squared, so x is 8. And then 9 and 11, we have x is 25, and then x is 8 root 2. All right, feel free to pause so you can go through these if you need to. 13, a rectangle has a length of 2.4 and a width of 1.8. Find the length of the diagonal. So the diagonal we'll call x, and then we have to square 2.4 and 1.8, and we end up getting x is 3. And then for 16, find the length of a side of a square with a diagonal length 12. And then here we go through, we use the Pythagorean theorem again. 17, we have a rhombus with diagonals that have lengths of 6 and 30. So when they intersect, they bisect. So we have 8 and 8 and 15 and 15. And then we'll have to go through to find one of the lengths of the rhombus. And when we do that, we find that x is 17. And there are 4 of those sides. So 4 times 17 gives us 68. And that will be the perimeter. Okay, so for 21, I split up this space into 3 and 3 to get 3 root 5 for x. For 23, same one like we had in class today, we had some different unknowns. So just be careful with that one. We had x is 12. 25, right? Making your own triangle here. So something that we just looked at. And then for 27, I did a few different things to find x and y. I believe x was one of the hypotenuses. So you had to find the hypotenuse, or the leg of the first one, and then that helps you find the hypotenuse of the second. Okay, so using the Pythagorean theorem. You can feel free to pause and rewind and look back at the work that I have here. Okay, and this one is a little different. So we have a right triangle that has legs of 6 and 8, and find the lengths of the median to the hypotenuse. And this is a theorem that we've already looked at before, so we know that when we draw a median from this left figure to the opposite, to the hypotenuse, we have congruent segments here. And so when we solved, we found x to be 10, right? So we know that's the case. So if we have the median of the hypotenuse, we know it's going to be 10. If we knew that from our theorem, you can just write that it's 10. But you can prove it using the Pythagorean theorem, using 6 and 8 to find the whole length is 10. So then you know that splits it up into 2 pieces of 5. And then for this other one, part B, the altitude of the hypotenuse, the altitude to the hypotenuse. So here you have a right angle, and you can use your means extremes if you want to. You can use proportions. So I got x is 4.8 here. So that one was a little bit different. Okay, so today we're going to talk about the converse of the Pythagorean theorem. So is any triangle with a side length 3, 4, 5 a right triangle? And you probably should have heard about these 3, 4, 5 right triangles already. And 3, 4, 5 right triangle is one Pythagorean triple. Okay, so if I have 3 squared plus 4 squared, that should equal 5 squared. And does it? Sure is. Okay. So to prove a triangle is a right triangle, we use the converse of the Pythagorean theorem. Okay. So if a squared plus b squared equals c squared, where c is the largest number, then it is a right triangle. So these are in the notes that you have. So this is the converse of the Pythagorean theorem. So initially for the Pythagorean theorem, we had it is a right triangle, so then a squared plus b squared equals c squared. But now we're trying to look at the converse. Okay, so let's look at this proof. We can talk through this proof a little bit. But we want to prove that angle S is a right angle. If we know that angle PQR is congruent to SQR, PRQ. PRQ is congruent to SQR, and PQR is congruent to SRQ. All right? Then we want to prove that angle S is a right angle. So since you know some lengths, right? Since 5 squared plus 12 squared equals 13 squared, is this true? It is true. Then we know that triangle PRQ is a right triangle. Okay? So, that we know. And we also could prove that lines are parallel. So this is the Pythagorean theorem converse here, right? This is the converse that we're using. And then from here, we can prove that lines are parallel through alternate interior angle converse, and therefore prove that we have a parallelogram. And then angle P would be congruent to angle S, using Pope, okay, parallelogram opposite angle theorem. And there's different ways you can do it. We could say side angle side, or sorry, angle side angle, and then we could use this as the reflexive angle side angle, and then we can prove that these angles are congruent through CPCTC. And then if we know that angle P is right, then we can look at this problem and prove that S is a right angle. Now, I'm not going to go through the whole proof of this. We can go through this the next time we see each other if you want, but it's just a different way to look at the problem using the Pythagorean theorem Converse. Okay, so in all the following theorems, C is the longest side of the triangle. So converse of the Pythagorean theorem. If a squared plus b squared does actually equal c squared, then the measure of angle C is 90 degrees. And ABC is a right triangle. Okay. Now, if a squared plus b squared is greater than c squared, then the measure of angle C is going to be less than 90 degrees. So this is a side classifying theorem for acute. I'm looking at the wrong one. It's acute triangle. Okay? So C has gotten smaller. Okay? So triangle ABC would then be acute. So these are things that we just have to kind of know. Okay, these are formulas we need to know, so refer back to these notes as you go through the next bit of the homework. And now if C squared is greater than A squared plus B squared, then C has gotten longer, okay, making this an obtuse triangle. So if A squared plus B squared is less than C squared, then the measure of angle C is going to be greater than 90 degrees, and triangle ABC is obtuse. So when you're looking at these to determine whether they are acute, obtuse, or right, the longest side is always going to be your C term. So we just have to see what we have. Right, if we have 25 plus 36, we need to know 25 plus 36, okay, what is that? So that's 61. Okay, 64 is greater than 61, so what kind of triangle do we have here? So look back at your notes, think about what it is. Okay, we have what kind of a triangle here? We have an obtuse triangle. Because your C squared is greater than your A squared plus B squared. So let's try the same thing for this one. So if we have 5 squared plus 12 squared, we need to think about if that is greater than, less than, or equal to 14 squared. So 25 plus 144, and then we have 196. So we're trying to figure out, all right, 25 plus 144, we have 9, 169, and then 196. Okay, so this is also an obtuse triangle. And then for 6, 8, and 10, if we have 6 squared plus 8 squared, we have to see whether that gives us 10 squared. So we have 36 plus 64. Oh, that equals 100, so I know that this is a right triangle. Okay. So here's a list of a bunch of Pythagorean triples, and Pythagorean triples we'll talk more about next class, but some common right triangle lengths. We have 3, 4, 5, and so there'll be multiples of those 3, 4, 5 triangles are some Pythagorean triples. And then from there, it builds up. So Pythagorean triples must be integers, so you can't have fractions and everything in between. So we can look more into that next class, but at least now you have a good amount of information to then do your homework
that's due tomorrow, which will be out of the textbook. So along with this, I'm going to say read through section 8.3, the Converse material, and you can look into some examples there. Okay, so I'll see you all on Wednesday.